G'day folks, welcome to a little equipment autopsy tonight. We have the Daewoo Lanos differential centre. This came out of a front wheel drive Daewoo transmission, well actually a General Motors transmission, a very common one, 5-speed transverse mount transmission. And we're going to take it apart as best we can and have a bit of a look at it. There's much to it. A differential is designed to differentiate drive between two wheels, particularly when turning. This is a front wheel drive car, so the drive shafts have to be able to drive and turn at the same time. And even in a rear wheel drive car, you do not want it fully locked and driving one-to-one at both sides, because the tyres will try and turn at the same speed, but they technically can't, so you'll squeal like mad going around corners. You can lock diffs up like that, and it can either snap axles or blow the differential itself, or just chew up your tyres pretty damn quick. But when you plant the foot mid-corner, the car goes around the corner like a slingshot. So the old SIG locker, or SIG welder locker, where you weld the spider gears together, does work and it does have its applications, but you're basically sacrificing the diff. So this is a front wheel drive one. It doesn't have a pinion gear or a crown wheel. Well, technically that's a crown wheel, but it's just driven off a drop gear in the transmission. It does not have a pinion that comes in, well, technically it'd be from this side. If it was a rear wheel drive car, you'd have a yoke, a pinion, and these teeth would be on an angle. So yeah, this is front wheel drive, and it's a lot simple. It's not so much simple, but it's just pretty straightforward. And the reason for the angled teeth, as someone pointed out on another video, these are helically, well, that's not helically cut, but I suppose it sort of is. You'll see that when I get to the transmission part. Angled teeth make less noise than straight cut teeth. Straight cut teeth whine. If you've ever had a manual car that whines like mad in reverse, or even many of them first, that's because the teeth are cut dead straight. If it doesn't whine at all, the chances are they're cut helically. So while it does put more thrust load on one of the bearings, the engagement is smoother. The teeth from the drive gear transition into the ones on the driven gear more smoothly and progressively. 1, 2, 3, part by part, rather than clunk, 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 like a straight cut gear. It's a bit hard to explain, but helically cut gears are quieter, smoother, and just work better. But they just apply a thrust load on one of the bearings. One of these bearings will be taking way more thrust load than the other one, depending on what direction you're driving. If it's in reversed, it might be thrusting this way. If it's in forward, it might be thrusting that way. Because of course it's the input gear is pushing against those teeth, and it's trying to push the whole centre to one side. Yeah, it's interesting. That is a speedometer transducer or encoder drive gear. It's made out of plastic, probably nylon. The signal sender for the speedometer would be up here on the gear case, and it has a little gear that comes down and, well, probably comes down at an angle and drives it. I've still got it in the parts cupboard somewhere. Yeah, here it is. It mounts into the gear case casting like so, and as the centre revolves, this revolves, and there's a, I think it's a hole type or something sensor. There's a magnetic wheel and a series of Hall sensors in there which send a pulse back to the, I don't know if it'd be straight to a computer or whether the dash cluster itself would have a decoder or whatever you want to drive for the electronic speedo in it. But either way, it just sends a pulse back at so many pulses per second or so many pulses per revolution that the computer interprets as a set speed. So they're pretty straightforward. Saves running a cable and a mechanical speedo, which are pretty much completely obsolete these days. But yeah, let's take this thing apart. There really isn't much to it. I'm not going to take the crown wheel off. I'm just going to drive this roll pin out, drift this big pin out, and drop the spider gears out, just so you can have a close look at that. There's really nothing else to it. It's a very simple device. But as I said before, it's designed to allow It's designed to deliver drive torque to both wheels while they are both spinning at different revolutions per minute. In a straight line, they're generally spinning at the same RPM, and these spider gears aren't really doing anything. But when you're turning a corner, those spider gears are actually turning because one wheel's spinning faster than the other. That's what I was trying to get at before. The inside wheel will only spin at a certain speed. If you're doing a U-turn, hard lock, right hand, the inside wheel is going to be turning fairly slow, but the outside one's going to be doing this. And you figure it out for yourself. If there's no slip in this, or no differentiation, you're going to try and twist one of the axles. And in the end, you'll squeal the inside tyre and possibly even shear the axle off back here. Probably right where the splines go into the spider gear, which is the worst place to try and do it because you've got to pull the whole thing apart. The differential allows a differential in drive speed, but applying drive to both wheels at the same time. Sort of, unless one just becomes completely dislodged off the ground, in which case it'll just spin. So, yeah, a limited slip diff's a completely different animal. I do not know much about them, but if I do find one, I'll try and figure out how they work and show you. But this is just a single spinner standard differential. I guess I better start taking stuff apart. It's been about 5 minutes or so now. It's one of those afternoons. Well, no kidding. I can't get the damn crown wheel or the damn pin out without taking the crown wheel off, of course. It's an idiot moment. Pin's free. That'll just float straight out once I get that off. And right now I'm absolutely murdering my compressor trying to get these thoroughly Loctited bolts out. Thankfully Alex sent me a decent rattle gun that really does its job. I need to buy a proper impact socket set because I'm probably going to murder this poor old Sid Chrome. It's actually a 516, but sort of works on a 14mm bolt. I've only got two 14mm sockets and they are not as thick or solid as that, so they would just explode if I tried to do that. But this one, no sign of bell mouthing just yet, but it'll probably be scrapped by the end of it. At least I've got a few of them. Imperial sockets, not a problem. Metric sockets, I don't have an awful lot of. Yeah, and none of these will do. These are all big ones. These are wheel nut or alloy wheel deep sockets, and these ones here are just normal chrome moly impact sockets. 17 up to, I think it's 20mm or something. That's a 19. That's a 21. So 17, 19 and 21 in deep plastic protected ones for alloy wheels, and regular short stubby ones. That's one of mine. That's a 18mm chrome moly, and there's also a 24mm for M16 bolts somewhere. I don't have a place in the casing for it, but it's a also the same brand, high impact chrome moly steel. See how much the compressor hates me now. There we go. That's a proper rattle gun. Well, it's not a 3/4 drive, but it's not quite a real man's rattle gun, but it's a rattle gun that works. A lot better than cheapo Chinese thing that I have at the moment. Before. There we go. And that's a crown wheel. Front wheel drive crown wheel. Okay, let's have another go at this now that I haven't left the crown wheel on. There's the main cross pin. So, yeah, oh, there we go. That's a thrust bearing. Normally I expect them to be copper coated, but I think most of that coating's gone now. There's one of the spiders. They're kind of cool. They look cool. Spider gears are always cool. There's one of the drive ones. You can see the splines that directly connect to the front drive shafts. That's all that's technically driving your car, is those little splines there. The rest of it doesn't matter. If those splines fail or the drive shaft itself breaks, you're kind of screwed. There we go. There's another thrust washer. Oh, sorry, thrust bearing, technically. That is actually a bearing. Not much to it. Another spider. That one there. That's its own thrust bearing. Pretty well worn. This transmission has a hell of a lot of wear in it. It's a nice big step worn on that one. Again, even the teeth on the crown wheel are fairly well worn, especially the little drop gear that comes from the transmission to the crown wheel. That is razor sharp. Like, this thing has never had an oil change. It's done almost, I think it's done almost 300,000 kilometres. There's another thrust bearing. And the other spider. And that's about it. Apart from the bearing races on the end, which are all pressed on, and the differential worm gear, that's it. So there you go. You've got the two drive spider gears for the drive shafts. The drive shafts just push into the spider gears and lock in with a little clip ring. They are all the bearings that take all the thrust load. And there's the intermediate spiders. Sort of sit in like that with the cross pin through them. Really cool stuff. Anyway, thanks for watching. I hope you learned something from my half-educated rambling. It's been a while since I played with this kind of thing. Oops, don't do that if you want to use them again. This isn't going to be used again, it's all pretty well shot. I spent a bit of time outside, so there's a bit of rust on everything. But yeah, General Motors Daewoo and just General Motors front wheel drive 5-speed 4-cylinder transmission, same as what's in the Opel cars, like Opel Astra, Opel Corsa, other similar GM products, more than likely probably in more than a dozen or so different cars, if not more. Daewoo or Chevrolet Aveo, quite a lot of different cars use this and still use it today. It's a solid little unit for what you pay for. A lot of people diss Korean cars, but to be honest, you're paying a lower price for a cheaper car. You can't expect a bloody Rolls Royce out of it. To be honest, if I had to buy a new car, I'd probably buy a new Hyundai common rail diesel with a manual transmission. Probably an iX35 CDI. I don't think I'd go the regular small car or sedan type thing. But if it had to be a new car, it'd probably be an iX35 CDI. Or maybe the Santa Fe CDI if they still make it. I don't think they do, but the last of the Santa Fe's, which had the common rail diesel in them, absolute beasts. Really torquey engines. And not all that expensive to fix either if you know where to get parts. So yeah, Korean stuff's not bad if you understand that you're buying a cheap car. Even the same with these horrible Chinese pickup trucks and things that they're selling over here. Great Wall Motors and all that. Some people hang shit on them for being cheap and plasticky, but hey, you're paying 19 grand for a work truck. What else do you expect? You want to pay 40 grand for a Hilux with all the options? Okay, fine. But if you want to pay even, I think it's lower now, I think it's like 16 grand, you can pick up a brand new 4x4 Chinese work ute. And, well, you get what you pay for. I've got no qualms about that. I buy Chinese stuff all the time, and I don't care if it breaks in 12 months. Oh well. thanks for watching, and stay tuned for more, because I've got to get into the rest of the transmission. That's going to be a whole nother box of rambles.